Hello, in this video, I'm going to talk about stress. So in this context, we're not talking about stress like emotional or physiological stress. Rather, we're talking about forces that are acting on the body and causing stress in the materials in the tissues of the body. Okay, so in this context, here's what stress is. So when we have external forces that act on the tissues of the body and cause deformation, those external forces act on the tissues, and as we know, there are equal and opposite reaction forces for every force. So when an external force acts on the tissue responds with an equal and opposite force opposing it. That is the stress. Okay, so stress occurs in the tissue because an external force acted on the tissue. So the stress is the response, it's the opposing force applied from the tissue back in the opposing direction. Now, we tend to talk about stress as if it is the external force itself. Technically, it isn't. It's the force in response to the external force. So stress would be an internal force in response to the externally applied force. But we tend to discuss it as if it's the external force that is the stress. Because when we're analyzing or discussing these properties, it kind of works out to be roughly the same thing. It doesn't make a very big difference when we discuss it in terms of external forces being applied to the body or the tissue's response to those forces. So in practical terms, it kind of is treated the same way. So the stress that is experienced in the tissues depends on the properties of the material, meaning the tissues. The internal forces can resist the deformation caused by the external forces. Okay, so essentially, external forces are applied to the body. So there are now stress is being experienced in those tissues. And in response to that externally applied force and the stress that's happening in the tissue, some amount of deformation may happen. And that's the strain, which I'll talk about in a separate video. Okay, so stress and strain are proportionate usually. Okay, so stress is applied to the body, and that causes some amount of deformation, which is the strain. Okay, so stress, when an external force acts on a material and causes deformation. Okay, so stress, the external force acts on the material, and that material responds with an equal and opposite force. So that is the stress. And that stress causes some amount of deformation, usually, and that would be the strain that happens as a result of the stress. Okay, so applied force divided by the area over which it is applied, that is the exact same formula as we had for pressure. Okay, that is how we calculate how much stress. So how much force, so this would be the external force. And again, we discuss the external force as being the same as the stress, and that's partly because it's significantly easier to measure the externally applied force than it is to measure the internal response to that force. So experimentally, we can measure the externally applied force, and we know that it's going to be equal to the stress. So that's why we use that as a proxy so often. Okay, so the stress is applied force divided by the area over which it's applied. That's exactly the same as pressure, but the difference is that with pressure, it's a compression stress. So with pressure, we're looking at when we apply a force and we divide it over the area, we divide it by the area over which that force was applied. That's pressure, which is a compression stress. So compression stress and pressure are essentially the same thing. We just use the different terms in different contexts, but we're discussing exactly the same thing. But what's different about stress in general versus pressure is that we have other stresses that are not simply a compression stretch. Okay, so stress can also be generated by a pulling tension where we're pulling in the opposite direction. And in that case, we're still dividing the area over, or dividing the force of that pulling tension over the area over which that force is applied. So the formula remains the same, but in pressure, it's only a compression stress, not a tension or a pulling type of stress. So a tension stress, That's when we have two collinear forces, so meaning two forces that have the same line of action that are applied to a material in opposite directions to pull apart. Okay, so in the picture here, that would be in the upper left, a tension stress, where we have a force, two forces that are happening in the same direction, not in the same direction, but that are happening in the same line of action in opposite directions to pull apart. So that creates a tension stress in that material. And then, because there's a tension stress, there might be some amount of deformation of the material in response. So like if we had a rubber band and we apply a tension stress where we're pulling it apart, then we're having deformation of the rubber band that's happening in response to our pulling, where that rubber band is now stretching, so it's getting longer and it's becoming more narrow as we do that. Okay, so that's an example of the strain that's happening in response to the tension stress that's being applied. Compression stress is exactly the opposite. It's where we have two forces applied to a material in opposite directions to press together. So exactly the opposite. We have two forces, but this time they're pointed toward each other instead of away from each other. A shear stress is when we have two parallel forces that are applied to a system, causing two parts of the system to simultaneously displace in opposite directions. Okay, so we see that in the bottom picture here, where we're looking at two blocks next to each other, and that we have a force pushing one forward and a second force pushing the other in the backward direction. Okay, so that's a shear stress where we have two structures or two parts of the same tissue that are being pushed in opposite directions relative to one another. So that type of stress in the body can create friction. And so when we have shear stress happening in joints, when that shear stress is in excess, then that friction can actually rub away and wear away at cartilage, and it can cause stresses on ligaments and tendons that they may or may not be able to tolerate, and so then that can cause injury that way. Okay, a bending force is actually when we have a combination of tension force on one side and compression force, or stress, I should say, on the other side. So with bending, we have two forces applied to whatever the structure is. Think about like if you're going to break a stick, you're going to bend this stick and it'll snap in the middle. You're applying two forces in sort of a rotary fashion like that to cause the bending. And so like if we look at the picture here all the way on the right, you can see that there's compression happening on the left side where the structure that's bending is getting smaller. We have compression happening on that smaller side where it's bending toward. And then meanwhile, on the opposite side, the material is being stretched. That's a torsion stress. So bending is actually a combination of compression stress on one side and tension stress on the other side. Torsion is when we have two forces applied to a system that cause rotation around an axis, but the two forces are going in opposite directions. Okay, so that's what we see in this middle picture here, where we have two forces that are causing a rotation, but they're causing rotation in opposite directions of the same material. So it causes sort of a twisting effect on that tissue. So torsional stress is responsible for a lot of knee injuries, like ACL injuries, sometimes PCL injuries, but not as often, more often ACL. And so torsion stress is, it's twisting a material, and maybe that material is designed to withstand that twisting, and maybe it isn't. So when we apply any of these kinds of stresses, there will be some amount of deformation of the tissue, that's the strain. And if we apply less stress so that it's within the tolerance of that tissue, then we have no injury. But if we apply so much stress to that tissue that we have more strain than the tissue can sort of cope with, then that's when we break the tissue. That's when we have some kind of injury. That's where we break a bone or tear a ligament or wear away our cartilage. Okay, so that's all I have for you in this video, and in the next one I will explain strain. Thank you.